This video is going to focus on factoring, in particular an emphasis on factoring out a common factor. So a quick definition of what factoring is, I've written at the top there, is writing a number or a term. So a number would just be like, for example, we're going to take a look at 24 here in a moment. Or a term would be if it has like a variable associated with it. As the product, so whenever you see that word product in terms of math, that tells us that we're going to be looking at multiplication. So we're going to look for something that would multiply in order to give us that bigger number. We're going to write it in that smaller number or terms. So our first example here is the number 24. We're asked to factor 24. So some smaller things that would give us 24, though the first one might be the most obvious for some people and not to others, but it is starting with the number itself. So 1 times 24. Then from there we can do 2 times 12. On this left-hand side, I'm going to be looking for increasing numbers. So I start off with the number 1. Any number can be written as 1 times itself. And then we look for 2. Obviously, if it's an even number, that means 2 goes into it. The next number I look for is 3. One of our tricks is if the digits add up to be a multiple of 3. So in this case, 2 plus 4 would be 6. That is going to be divisible by 3. 3 times 8 gives us 24. If I look at 2 here, since this is also an even number, I can know that 4 is also going to multiply to give us 24, and that's going to be 4 times 6. The next number in line, again, I'm increasing here on the left-hand side, would be 5. Since this number doesn't end in a 0 or a 5, we know that this number is not a multiple of 5. So then we look for 6, and we already have 6. So once we've kind of wrapped around here, we've gone through every possible number that's less than 6. And now I can tell you that those are the only numbers that are going to multiply to give us 24. We can do that same process with 121. We can start with 121. 1 times 121. That's always a good starting point. Because this number right here is odd, that tells us 2 isn't going to work. If I add up the digits, 1 plus 2 plus 3, 1 plus 2 is 3, plus 1 is 4. So since that's not a multiple of 3, this isn't going to work. Then we need to look at 4 as an option. Since 2 didn't work, that's not going to work. And you can keep going all the way up with that. 121 is a multiple of 11, however. It's 11 times 11, or 11 squared. So those are all of our factors of 121. I can tell you that whenever you loop back around to that next number, or you hit a point when you have the same thing on both sides, in this case a square, that's when you've reached the end. That's when you are done. That is what factoring looks like. Down here is a slightly different way of asking that same type of question. What is the greatest common factor? So greatest tells us that we're looking for what number is the biggest. Common says it needs to be in both of them. So common means has to be in this list of numbers and in this list of numbers. And then factor tells us that we're looking for a product. So we're looking for something that is a multiple that is in both of these lists, but we're looking for the biggest. So you might see that abbreviated in the future as the GCF, the greatest common factor. So when I want the greatest common factor of 48 and 196. So I make my list just like we did earlier, and I look for what's the biggest number here. So I can start with like what is my biggest number and then look for that in the other list, or I can just start with the smallest and look for where do they stop having something in common. So I might start, for example, with 2, look for that. Hey, we have a 2. Do I have anything bigger than a 2 that they both have in common? Yes, we both have a 4. Both lists have a 4. They also had that 2 in common. Let's see if there's anything else. So I have a 6 here. I don't have a 6 over here. I have an 8 here. I don't have an 8 in this list. I have a 12. Nope. 16. No. 24. Nope. And 48. Nope. So our greatest common factor, our GCF, that number is 4. That's our answer. It's the greatest number that both of those have in common. Earlier, if you remember our definition, we said that it could be a number, but it could also be a term. So down here, I have some math terms. So we have 8. If I factor that number, we said 1 times itself is a good starting point. Then I can move up to the number 2. 2 goes into 8 because this is even, so that's going to be 2 times 4. And 3 wouldn't work because 8 is not a multiple of 3. Then when we get to 4, we're back around. We've looped back around in that list. X squared is the variable x times itself. So I could add that on to each of those, and that would be the factored form for each of these expressions. It could be 1 times 8 or 2 times 4. And then x squared is x times x. That's a representation of this. I've just written it in 2 separate ways. Over here, we're asking for what is the greatest common factor of 8x squared minus 12x. So I already have my list over here of things that multiply together to give me 8x squared. Now I just need to think about things that would multiply to give me 12. So that's 1 times 12, and then I can increase this left-hand side by 1, and I have 2 times 6. 3 times 4, and then we've looped back around. And all of those, we're going to stick an x on. So as I look at both of those lists, I'm looking for what is the greatest common factor. The greatest is the biggest number that appears in both lists. And I see there's a 4 that appears in both lists. When I kind of identify that one row, these other rows that have numbers that are helpful, but maybe not the most helpful because we're looking for the greatest common factor, I want just the numbers that would multiply to give me 12. I don't want any of these other repeated numbers or duplicate numbers. So I look here and I see that, all right, I have a 4 in each of them, but what else do I have in common? In addition to having a number in common, we also have a variable in common. So we can factor that out. You'll often see it written like this, with a parenthesis, and whatever we had left over, that will go inside the parenthesis. So in front of this, we had the 8x squared, that's this term over here. What we don't have underlined is we don't have a 2, but we also don't have one of our x's. So that's going to be a 2x. Over here, what did we have in common? Well, we had that 4x, that's gone. So what do we have left? We still have that 3. And since there was a minus sign out front, that's going to be my answer. So that's what factoring out a greatest common factor or the term that they both have in common looks like.